find a vector B that is 4 times as long as the vector A in the same direction as A. So let's think about it. As I said a lot of different times, that's not what I wanted to do. As I said a lot of different times, if we have an I hat axis and a j hat axis, we can extend this principle to 3 dimensions, but it's a little bit easier for me to demonstrate in 2 dimensions given that I am not a very good drawer. So if I have a vector, let's say vector A, and if I have a vector A and I multiply by a scalar, I'm constrained to remain on this line. I mean, I could go back, but that's pretty much it. So I know that if I want a vector that is 4 times as long as A, I simply need to multiply A times 4 to get a vector that is 4 times as long. This is not to scale, but that's the idea, right? So the only thing is that I don't really have a representation of the length of A. So I have to do it to its components. Now A, the A vector, is equal to, if I convert this engineering notation, it's got a coefficient of 1 in the I, so a component of 1 in the I direction, a component of -1 in the j hat direction, and a component of 1 in the k hat direction. So the magnitude of this vector is going to be 1 squared plus -1 squared plus 1 squared, which is really going to be the square root of 3. Now, how do I go from the square root of 3 to 4? Well, I like to go this way. I like to say that 4 times A, I want to get rid of the square root of 3, so I multiply by 1 over the square root of 3, and on top, I'm going to put a 4. And that's going to give me, well, actually, I made a mistake. So we don't want the length to be measure 4. We want the length to be 4 times A. So all we have to do is just multiply it by 4. So that's just going to be 4 times the square root of 3. And now I know that that's going to be the scaling factor for my components as well. So I need to multiply A's components. 4 times A is just going to be equal to 4 times the square root of 3 times 1 minus 1 and 1. And if you do that, then that's going to be 4 square root of 3 minus 4 square root of 3 and 4 square root of 3. Okay, so that's 4A, just like that. And that would be my final answer for this question, because this is 4 times our original vector, and it's in the same direction because I multiplied by a scalar, so I was constrained on that direction in the first place.